don't make the trick, so you know we bout to turn.
Yo, what's going on, man? We're looking at our test before the Thanksgiving break. We got Unit 7 test review, and I am your host, Coach Moore, and we will navigate through Unit 7 in preparation for your test. So that being said, let's get started. Alright, so in this first example right here, so if y varies inversely as x, what that means is y equals k, our constant. K is a part of all these equations, guys, all over x. Alright, now they tell us that y is 7.5 and k is k and 8 is x. We always have to find k. K goes first, okay? So now we're going to solve this to find our constant. Right here it says find our constant of variation, which is k. Well, we're going to multiply by 8 on both sides. All right. Oops, that's a terrible parenthesis right there. So 8 times 7.5 is 60. So 60 equals k. So now that I know what k is, I can go and answer the rest of this problem. It says find y, all right, when x is negative 10. All right, we know k is 60. All right, if you look back at the original equation, y equals k of x. So when we do that, 60 divided by negative 10 is going to be negative 6. So y equals negative 6. All right, that's why. Determine whether each data set represents a direct variation, inverse variation, or neither. All right, let's do a quick review. When we do x times y, and we get a constant product, that is going to be that's going to be inverse. Alright, this is inverse variation. Alright, and when we do y over x to get a constant ratio, alright, that is going to give us a direct variation. Direct variation, okay? So write that down somewhere so you have it. X times y is the inverse variation. When I get a constant product, y over x gives me a constant ratio, okay? So now looking at this example right here, I'm going to start with x times y. I'm just trying it, x times y. Let's see what I get. All right, so I have 6.5 times 8. That's 52. And then I have 13 times 4 right here. That's 52. All right, because still we're doing x times y. And then I have 104 times 0.5. That's 52. So see how I use x times y and I multiplied it and I got a common ratio right here, a constant ratio, everything's the same. Well, that is going to be a inverse variation, okay, inverse. All right, because I multiplied to get a constant product. Now right here, we're going to do x times y, all right, or xy. Well, 5 times 30 is 150, and 8 times 48 is going to be 384. So I'm going to start right there. See how these aren't even the same thing? So it's not a common ratio, and I can tell that right now. All right. So now I'm going to do y over x. Why y over x? Because that's the only other thing to try. Alright, y over x. So now we have y over x, so we go 30 divided by 5, that's 6. And then we try this one, y over x, so 48 divided by 8, that's 6. And 72 divided by 12, that's 6. Alright, so because we have these 6's right here, alright, we can say that this is a common ratio, or constant ratio, excuse me. So we're going to say that this is a direct variation. Direct variation. Man, that's terrible writing. Let me try to fix that. There we go, direct variation. Okay. Alright, now on to the good stuff. Simplify as indicated. All right, to simplify this, first of all, some of these are not written in standard form. We're gonna put them in standard form. All right, what's this one really? Okay. So, and I'm also gonna keep change flip. I'm gonna keep this first one here. All right, I keep the first fraction. And then I change the division sign to multiplication. And then I flip this one, all right? So I have x squared minus 4x. And then I'm going to write this in standard form right here, which will be negative x squared plus 3x plus 10, like that, okay? So now what we got to do is factor everything. So this one, we're going to factor out 4. So it's going to be 4. I'm going to do it in another color. We're going to go 4 times x plus 2. Down here, we're going to factor out a 5. So we have x minus 4. Up here, we're going to factor out an x. So we have x times x minus 4. And down here, I'm going to factor, well, here, first I'm going to factor out a negative. All right, so let me make sure that's clear. If I factor out a negative, it gives me negative 1 times x squared minus 3x minus 10, like that, all right? The signs change, everything changes. And then I'm going to factor this, all right? So when I factor that, it's going to be two numbers that multiply to give me negative 10, that add to give me negative 3. I'm going to go x minus 5, x plus 2. All right. So now everything is factored. Now I can cancel out things, okay? So right here I have, all right, sorry about that. So we're going to factor out x minus 4. We're going to factor out x plus 2. All right, so now what we have left is 4x at the top, and at the bottom we have this negative, that 5 times x minus 5. All right, so you can leave it right here, or you can, all right, so there we go right there. All right, or you could simplify the bottom to get negative 5x plus 25. All right, like that. So either one's acceptable, okay? All right, if you need to see it, just rewind it. Take it back a few minutes. Let's go ahead and do number 4. Excuse me, number 4. This one's multiplication, so we are going to factor everything. All right, factor everything. So I have the top right here, I'm going to factor out a 2. So that gives me x squared minus 6x minus 7. All right, and then right here, I'm going to factor out an x. So I'm left with x squared minus 16. All right, so I'm actually going to factor this again. If you remember, x squared minus 16, that's the difference of perfect squares. So that actually becomes x plus 4. X minus 4. All right. Well, you know what? Here, because I got to factor the top again anyway. So we'll leave it right there right now. X squared minus 16. Then up here, I'm going to factor out a negative 4. All right, because I want that x to be positive. So I factor out a negative 4. I have x plus 4, because negative 4 times x is negative 4x. Negative 4 times positive 4 is negative 16. And then 6 right here, I'm going to factor out a 6. And I'm left with x minus 7. Okay. So now let's factor these two again. All right. And doing so, we have 2 times 2 numbers that multiply to give me 7, but add to give me negative 6. Excuse me, negative 7 plus 6 is going to be x minus 7 and x plus 1. Remember down here, this is the difference of 2 squares. So you have x times x plus 4 x minus 4. Right here, it's already factored. Negative at 4 times x plus 4. And 6 times x minus 7. Now we can cancel things out. This is going to cancel with this. And plus 4 cancels with this plus 4. So at the top I have 2 times negative 4. That's going to be negative 8 times x plus 1. And at the bottom we have x times 6, 6x times x minus 4. Now, I'm going to cancel one more time. This right here, 8 and 6, if you simplify that, they both divide by 2. So that's going to be 4/3. So negative 4 x plus 1 all over 3x. 3x times x. Sorry about that, x. Times x minus 4. Like that. And then we can simplify that, guys, if you want to. Negative 4x minus 4. All over 3x squared minus 12x. Alright, final answer right there. Alright, number 5. Number 5 here, first of all, is a division problem, so you gotta keep change flip. So we're gonna keep the first fraction, change this from division to multiplication, and then flip the last fraction. So we have 3x minus 4 at the top and x minus 1 at the bottom. And now we look to factor. Well, everything seems to be factored. So from here, we just cancel out what we can cancel out. We can cancel out 3x minus 4. So we're left with 2x plus 1 all over x minus 1. All right, so final answer right there. All right, let's look over here at number 6. Number 6 is multiplication, so all we gotta do is factor everything. All right, at the top, we can factor out of 5, so we're left with x minus 3. Down here at the bottom, this is the difference of 2 squares. All right, so we have x plus 3 and x minus 3. And then at the top right here, we can factor out of 2, so we're left with x plus 3. And at the bottom here, we have a single 5. Now, everything is factored. We can cancel out. Let's see what we can cancel out. We can cancel out the x minus 3. We can cancel out the x plus 3. We can even cancel these 5. So we're left with just 2. All right, so that's number 6. All right, number 7. All right, number 7 is a division problem. All right, now you know that because there's a long line of division right here. So we're going to still do keep, change, flip. We're going to keep the first fraction. All right, this is the first fraction. And then this is the bottom fraction. All right, we're going to keep the top fraction, change the bottom fraction, or change it to multiplication and flip. So what we have is 1 minus x squared So there we go. Now, right here at the top, man, we actually have the difference of 2 squares. Yeah, but I want to factor out a negative first. I factor out a negative, and so we have x squared minus 1. All right, the signs change. All right, once you take out a negative. All right, so if you multiply the negative back, you'd have negative x squared plus 1, like that. So I took out the negative, okay? So now we're going to factor that again. Since it's a difference of 2 squares, when it's x squared minus 1, we're going to factor that to be x plus 1, x minus 1. And now at the bottom, if I factor this, x squared plus x minus 1, all right, 2 numbers that multiply to give me 1 that add to give me 1. All right, so This one, guys, if you look, that's going to give us an imaginary number because 1 times 1 is 1, but there's no factors of 1 that they add to give me 1. So for right now, we're going to leave that as x squared plus x plus 1. All right. Up here, there's nothing to factor out, so you just have x cubed minus 1. And then down here, this is factorable. We have 1 times 1 to give us 1, and well, actually, negative 1 times negative 1 will give us a positive 1. And negative 1 minus 1 will give us negative 2. So we have x minus 1 times x minus 1. All right, so this one right here, guys, is the difference of cubes. So if you remember SOPs, all right, which hopefully you do, what you get your 2 terms, x minus 1. All right, and then you have SOPs. All right, so square the first term, square that first term, that's x squared. Opposite sign, so this is minus, so we're going to go plus. And then we have the product of the 2 terms, so x times 1 is going to be 1x. And then you have right here, p is for plus, and then s stands for square the last term, so 1 squared would be 1. All right. All over this right here, we're going to factor that. You have 1 time, or negative 1 times negative 1 is 1, and negative 1 minus 1 is negative 2, so you have x minus 1, x minus 1, okay? So now we can cancel things out. We have the x minus 1s right here. We also have this x minus 1. We also have this x squared plus x plus 1. That can cancel with this one. All right, so all we have left is this negative x plus 1 right here. All right, that's all that remains. All right, now let's look at number 8. Number 8, again, factor everything that you can. So we have x plus 1 is already factored over x minus 1 times x squared all over, that's the difference of 2 squared, so we have x plus 1 times x minus 1. All right, so this x plus 1 will cancel with that x plus 1. So I'm left with x squared all over x minus 1 times x minus 1. All right, which you can write it as x squared over x minus 1 squared, or like this, or make it a trinomial, x squared minus 2x plus 1. Either of these is acceptable. All right, they're all the same thing. All right, number 9. All right, again, right here, I would like to division, so let's keep, change, flip. So we have, keep the first fraction, 1 over x. Actually, you know what, here, yeah, negative x plus 1 times x plus 1 all over 1, right? Keep, change that to multiplication, and flip this. Now, obviously the ones are going to cancel, but before that, right here, let's see. Do I want to take out a negative? That'd be x minus 1. Nothing to cancel. All right, so yeah, here we go. We have the ones are going to cancel. So I have x plus 1 all over negative x plus 1. And I know you're like, oh, well, that's the same thing. No, it's not. That's a negative x. All right. If I were to factor out a negative out of the bottom here, all right, if I factor out a negative, what I have is, remember, the signs will change. So the x is now positive. The 1 becomes a negative because, look, distributed back. Negative 1 times x is negative x. Negative 1 times negative 1 is positive 1. So these will not cancel, okay? So your answer could be here, all right, or here. All right, they're the same thing, though. All right, but you cannot cancel that out because they're not the same thing. All right, number 10. Number 10, all right. Let's factor everything. All right, so we factor this top. That's the difference of 2 squares. So we have x plus 3 and x minus 3. If you look down here at the bottom here, what two factors will multiply to give me 4 but add to give me negative 4? That's going to be x minus 2 and x minus 2. And then right here we have the difference of two squares again, which are going to be x plus 2, x minus 2. And then finally, right here, this trinomial, what are two factors that will multiply to give us negative 6 but add to give us negative 1? That is going to be x minus, hold on, let me keep it all red. X minus 3 and x plus 2, okay? So now we cancel out things, all right? What can we cancel out? Well, let's see. Right here we have an x plus 3, all right? There's not another x plus 3. There's an x minus 3 right here. I can cancel that with this x minus 3. Then there's an x plus 2. I can cancel those out. And the x minus 2. I can cancel those out. So I'm left with x plus 3 all over x minus 2. Final answer. Where do you find them? Alright, number 11, people. Keep, change, flip is division. Alright, I'm going to factor as I work. Hey, look, there's paper up there. You don't have to open that. Just get it out the top. We got to factor this. So we have 2x plus 12. We're going to factor out at 2. So that is x plus 6. Right at the bottom, we factor out at x. So that's going to be 2x minus 5. Then we're going to change that to multiplication and flip this. So we have 2x minus, that's a terrible x. 2x minus 5 at the top. And at the bottom, I factor out at 3. So I'm left with x plus 6. Now, what can I cancel? 2x minus 5 and x plus 6. What am I left with? 2 over 3x. They clearly went home and did nothing last night. It's obvious. Alright. This one. Alright. Let's factor. Well, x plus 3 is x plus 3. X minus 1 is already simplified. Now we're going to simplify this right here. What two factors multiply to give us positive 1 that add to give us negative 2? X minus 1 times x minus 1. Then right here, what two factors multiply to give us 6 that add to give us 5? X plus 3 times x plus 2. Now, what can we cancel out? The x minus 1 can cancel. What else can cancel? The x plus 3 can cancel. And I'm left with x minus 1 at the top. And I'm left with x plus 2 at the bottom. All right. Number 13. Number 13. Again, division. Keep, change, flip. So we have x plus 2. I am going to factor as we go. Two factors that multiply to give us negative 15, but add to give us negative 2 is going to be x minus 5 times x plus 2. X plus 3, excuse me. Alright, that'll give us negative 15, but if you add them, you get negative 2. Now I'm going to change this division to multiplication and then flip this. Alright, keep, change, flip. Now what cancels? X plus 3 cancels. Alright, so I'm left with x plus 2 at the top. And at the bottom, I have x times x minus 5. Alright, you can, this is acceptable, or if you distribute the x down here, you have x plus 2 all over x squared minus 5x. This is acceptable as well. Either one will work, okay? Alright, finally, number 14. Keep, change, flip. I'm going to factor as we go. Two numbers that multiply to give me negative 8, but also add to give me negative 2. We're going to go x minus 4 and x plus 2. All right, negative 4 times 2 is negative 8. Negative 4 plus 2 is negative 2. At the bottom right here, two numbers that multiply to give us negative 15, but add to give us negative 2. All right, it's just like this one, guys. All right, so that's x minus 5 and x plus 3. change that division sign to multiplication. Up here at the bottom, that's now the top, I'm going to factor out a 2x. So I'm left with x minus 5. All right, just a quick check. 2x times x is 2x squared, and 2x times negative 5 is negative 2x. And now factor out a 2x again. I'm left with x minus 4. Quick check. 2x times x is 2x squared, and 2x times negative 4 is negative 4x. Negative 8x, excuse me. So now, what can I cancel? I can cancel x minus 5 and x minus 4. And 2x. So I'm left with x plus 2, x plus 2 over x plus 3. Final answer. All right. Now, solve each equation. All right. Remember these right here, you want to cross multiply. But remember, see how you have the same denominator? All right. Well, imagine if I multiply by x plus 4 over here and x plus 4 over here. These cancel. So now I'm just left with x minus 2 equal to 5x minus 10. Now I just solve for x. I'm going to move this over to the larger x value, so I'm going to go minus x. 5 minus 1x is going to be 4x, so I have 4x minus 10 equals negative 2. And then I'm going to add 10 on both sides. So we have negative 2 plus 10, x equals 8. All right. But actually, no, you don't. All right. So plus 10, that gives you 8, right? Equals 4x. So now you got to divide by 4 on both sides, and you get x equals 2. All right. The one thing I didn't do was at the beginning. Let me clear this off so you can see it. You have to find your extraneous case. Look at the denominator. X cannot be equal to negative 4. All right. So there's our answer. X equals 2. All right. And it cannot equal negative 4. All right. For number 16 right here, you need to cross multiply. Okay. So we're going to do x minus 2 times 3. And we're going to do 8 times x. All right. Distribute the 3. 3x minus 6. Sorry about that. And over here we have 8x. Now, before I continue, look right here in your denominator. All right. X can't be 2. And this one, x can also not be 0. All right. Because it's just x. You take your denominator, set it not equal to 0. It can't be those two things. Now we're going to subtract 3x. So we have negative 6 equals 5x. And then divide by 5. X equals negative 6 over 5. Right there. All right, and here's our restriction as well for extreme solutions. For number 17, all right, we have, again, see the denominators are the same? All right, so if I go r plus 2 on the, well, first of all, r cannot equal 2. Let's go and make that clear. All right, those are the denominators. So if I multiply by r plus 2 on both sides, it cancels. So I'm left with 12r equals 4. Now I divide by 12, and we get r equals 1/3. Over here, look at my extraneous cases. All right, well, for this one, we know that d cannot equal negative 2. And then for this one, you have d squared minus 4 not equals 0. All right, we're going to add 4, so you have d squared not equal to 4. And then square root both sides, d cannot equal plus or minus 2. So we're also going to add positive 2 to that restriction. It can't be negative 2 or positive 2. Okay. Now, anyway, we cross multiply. All right, cross multiply. So you get, well, actually, I'm going to factor this, and I'm going to show you why. I have 10 over d plus 2 equals 5d over d plus 2, d minus 2. That's the difference of 2 squares. So now, see how these denominators right here are the same, this one and that one? So once I multiply by d plus 2 on this side, they're going to cancel out. So I'm left with 10 equal to 5d over d minus 2. Now I multiply this side by d minus 2. Alright, and this side by d minus 2. That way they cancel. So now, real quick, distribute the 10. So I have 10d minus 20 equals 5d. Well, I'm going to subtract 10d, so I have negative 20 equals negative 5d. Alright, and then divide by negative 5. So d equals negative 20 divided by negative 5 is 4. So d equals 4. Alright. Right there. Alright, last problem, number 19. It says, look at the student's work. If it is correctly simplified, what values could make this expression undefined? Alright, first of all, here's the problem. Alright, this is the difference of two squares, so they factored right here, got 2x. X plus 2x minus 2. Right here, this is not the difference of two squares, so all you can do is factor out the GCF, which is x. Alright, so this top part is right. Alright. Yeah, this top part is right. Now the bottom, let's check that. Right here we can factor out an x, so you have x times x minus 2. And right here you need to factor this, two numbers that multiply to give you 2 and also add to give you 4. Two numbers that multiply to give you 4, excuse me, that add to give you 4 is 2 and 2. So that bottom is right. All this is factored right. So now let's see what can be canceled. Let's see, this positive 2 right here and that positive 2, this negative 2 and that negative 2, this x and that x can be canceled. Alright. And so I'm left with x minus 1 over x plus 2. This is right. Alright, the student work is correct. Alright, so that's correct. Alright. But now let's backtrack to where this thing is undefined. Alright, well, to figure out where this is undefined, remember, you take all your denominators that are factored. You have x, set that not equal to 0. You take x minus 2, set that not equal to 0. Take x plus 2, set that not equal to 0. And see how there's 2 of them, so we only need 1 because you're going to get the same answer. So we simplify each one, or solve for x for each one. Well, with this one, x is not equal to 0. There's nothing to solve for. Alright, x is already not equal to 0. For this one, you're going to add 2 on both sides, so 0 plus 2 is 2. So x is not equal to 2. And for this one, you're going to subtract 2 on both sides, so 0 minus 2 is negative 2. So x is not equal to negative 2. Guys, here are all the restrictions. This is where this polynomial right here will be undefined. All right, well, that concludes your video, and I hope it helps.